So yes, hey everyone, I'm very pleased. The DEI installation has started in my small engine room. The handle is already hanging. It's about to arrive. DEI, the inverter, it's going to hang so ugly, because people used to hang it, and now inverters hang. Okay, it can be. I'll hang the inverter. I'll take care of a little bit of syphilis that has arisen. On the forum you asked about the troughs. Are the troughs connected to each other? Of course, they are connected, and all these troughs are twisted together. All those on the wall, as well as the vertical ones. The point is that they are all grounded, so to speak, not literally, because the ones on the wall are not yet connected to the balance rail. The hanging ones are already in the basement next door. But these will still be separately connected to the rail here to make it safer. You see, they are twisted together. I don't know if you can see it. You can see, they are still all in brick, but in a moment I will start cleaning and we will move on with the subject of installation. It didn't leave me alone. And he hangs for his sins. I'll tell you honestly. The specific is the connection. As for the battery itself, actually not. The 300A has to go somewhere. Say, on the other hand, I didn't see that there was a fuse here. B50 the beginning was thrown, I don't know if you can see, with Eaton, somehow it reads like that. I have already let it as part of relaxation and rest from lifting it on the handle. Because it is quite high, the temperature sensor for the batteries. For now, it is run like this for a short time, and to be honest, I don't like it. Whether it's resistance or something else. Because I would like to have each of these series monitored to some common temperature and pulled out of an average temperature. So I'll probably do something on the Arduino to make it calculate the average temperature for me. I think it would be the most advisable. So it will go up somewhere, my average will be pulled out. I'll roll up the probe, because I have to unwind another cable here. Well, I'm getting down to further work. The only thing left to do is to fasten the negative wire and do the test. Rather a test on an energy storage. Because the tests are already taking 2 days, really. I'll show you what we have connected. We have here in the first ports, the first 2 ports are the temperature sensor. The remaining 6 ports are transformers, which are connected 20 meters away. I have it configured for a microinverter. And in this case he is talking to the sofa, so the sofa is directly connected through the switchboard here, where the Hodgmulsi will also be plugged in. This is the middle one. And he flies to DEYE. And DEYE simulates the creation of a network, or rather an uprising, simulates a professional network for him and captures all the energy from him. A nice thing is that after installing the transformers, DEYE can also power the device after the grid, which is where we give the lift back to the grid. In my case, it will look like this. I will definitely test it at the beginning, that I want to power the heat pump on the grid. So the transformers measure that. For example, there is 2.5 kilowatts taken from the store and grid, and DEYE will take these 2.5 kilowatts from the energy storage and send it in that direction, so that nothing escapes outside. We'll see how it works, how it will perform. I'll probably also have a surprise for you. I'll get something for testing, but that's later in the video. So you could say that I've been testing DEYE for an hour and a half. I'll show you my settings and in general what's here, what we have here. Here we have a grid, i.e. what the inverter takes from the grid. Here we have how much the house consumes, and at this stage I would like to point out that it is like this. The house is connected to the load input, i.e. the guaranteed input, and supplies the heat pump through greeter, i.e. what goes to the main switchgear. Photovoltaics currently produces 83 W. Well, it's 8:30, so something is happening. Okay, I'll leave. The battery is 93%, 2.5 kilowatts is flying from the battery. Oh, the light is reflected. Maybe it will be better this way. I will try not to cover it. I'll show you more or less my setup now. We go to the main panel. We have batteries here. I have batteries by percentage. I set the capacity to 260 Ah. The maximum charge is 80 ampere. We have the middle section here. I set the maximum discharge to 105 ampere. Due to the fact that I have not tested the warehouse under maximum load, so I want to do it calmly and to be safe. In any case, AGMs are on a smart. No problem. Let's see, there's something below. Here we have the battery settings, i.e. when the battery is to turn off at 35%, low battery discharge of 45% and the place where the battery is to return, i.e. for example, if it is discharged, it will charge to 55% and only then will the inverter start using it. Moment. Okay, basic. Here we only have the date, the time. From the videos that I also saw about DEYE configuration, I turned off BIP, i.e. beeper. Due to the fact that when you do something here, connect it, I practically tested something every time I connected the cable. Here we don't have any menu under the menu, so let's move on to the next tab. Here I have set 0 export to CD. At the moment, he uses transformers installed in the switchboard at the output towards the torrent meter. The solar cell option is simply that I want to sell the surplus energy to the grid, so I have it checked in both cases. For now I will test this version. When it comes to what the inverter is supposed to do first, it is supposed to handle battery charging first, and then everything else. Let's see if there are still settings here. I set myself such a schedule. I don't know how reliable it will be. You know, this is the first startup of this inverter, the first startup. I'm sorry, because that's the difference. Why did I set it this way? Because normally the sun is shining there from 7 o'clock, so this consumption and self-consumption is somehow greater. From 4:20 p.m. to 7:30 p.m., it can discharge up to 65%. This is to feed the warehouse. I also want to see how much the voltage will drop to. I don't know if I showed here at the top we have to indicate that he should use this schedule. And there is nothing left here. Grid. I set the frequency to 50 Hz. In fact, I don't think I even changed anything in these settings here. But I'll tell you in a moment. No, I didn't dig here. Here is everything, so to speak, as it was in the original. And in fact, according to so far. Okay, wait a minute, I'll get out of here. Generator port. I have a microinverter marked. Because I have a software connected to this DEYE, which hangs there at the end, and I can already see that it is shining, no longer blinking, so maybe in a moment it will graciously produce something. And that's it. I didn't configure anything else here. I don't think there's anything else here either. I practically didn't mess with the advance. So I won't even tell you what exactly is being set here. And we also have too much. Well, this is certainly where the chain pilers are placed. That is, master, slave. What else do we have here? Device info. These are practically errors that I encountered during installation. And that's it. And that's it. Here in the schedule, in the charts, there is practically nothing, because the hour of 40 minutes is whizzing by. What do we have in the battery? 91% battery, 52V, and that's it. At the moment it produces 93W and DEYE eats it all up and converts it into self-consumption. And the change took place very quickly. I switched the display to V, due to the fact that I had already noticed things that would get out of my control. I'll show you. I changed the schedule, turning off the battery at 48.5V. Volt, low battery information at 50V. Restart, i.e. when the inverter is to start using again, i.e. it can start drawing energy from the battery, when the battery reaches 52V. Of course, the schedule fell apart right away. Sorry, I escaped you again. I'll show you. There was a schedule here. No. Oh, there was a schedule here. I changed the schedule a bit. The schedule now looks like this. It is no longer in percentages, but in volts. From 7 AM to 4 PM, it can discharge storage up to 54 volts. From 4:20 PM to 7:30 PM to 51 volts, the voltage can drop. And from 7:30 PM to 7 AM to 49 volts. I didn't set the rest of the schedule, these values are some random ones that were set. And I did practically nothing else. But let me tell you, after changing these settings, the network looks completely different. It should also be noted that the heat pump has stopped working, or rather stopped working, turned off. So at the moment it is not heating, the load on the house has also decreased. We draw 20W from the grid, that's how it would come out, right? Yes, 20W. Wait, I'll just find a button, with a 30W grid. DOM consumes 570W. 37W is running from the battery at the moment. 12W from photovoltaic panels connected to DEYE. And I think that now these settings are good. Rather good, good for further testing. We'll see what happens during the day. I'll definitely record a video and I'll try to show it to you as soon as possible. Hey,